my first programming, like my first encounter to programming was when I was 9 years old. My dad opened up the terminal window on the next computer, and he started typing. And he was typing and typing and typing, and while he was typing, my expectations grow higher and higher. And then he clicked enter. And there were 2 words coming up, and that was hello world. And that was my first and only experience with Java. Thank God. Luckily, there are other programming languages to choose from, right? And when I found a programming language that I really liked, and that was kind of somewhat better suited for a kid, at least in my opinion, it was like an entirely new world was opening up to me. And I could build and create whatever I wanted, however I wanted, could spend as much time as I wanted on building something here, and then I could go build something here and go back and start on the first thing again. And after a couple of years, I also realized that programming is fantastic for solving problems, and in particular, it can be an amazing tool for improving the physical environment and make the physical world better. It's very easy to get stuck in programming and what we build, which is great, but also to see the purpose with what we do and that we actually make the world better somehow. So that's what I'm working with at the moment. Working with carbon mitigation using Erlang and energy efficiency. So let's get back to the question. Can you teach a school class functional programming? And today I want to talk about why, how, and then somehow a conclusion in the end. When I get the question, what's your favorite programming language? Like, that's a question that often comes up, like when you meet a new colleague or someone at a hackathon or a conference, which is not this conference, obviously, then I usually answer this normal, like, I always like to choose the right tool for the job, but in the end, there is Erlang. And then I get the answer, like, really? And then either someone says, oh, I tried that one in university, I never tried it again. Or they say, ugh, why do you do that? Or they say, oh, that's really difficult. How can you program in Erlang? And I never really understand those questions. So there is an understatement that I got really surprised when I had a job interview a couple of years ago. And I also asked, oh, what's your main programming language? And this person that was sitting opposite to me, he was saying, oh, yeah, you know, I programmed Java for quite some time, but lately I tried Erlang, and I really like it, and I think that's my new favorite. And he got the job. And he's sitting there. Hello, Tom. Can you wave? Yeah. Tom is actually the reason why I'm here at all, because one Monday morning he entered the office, and he said that I feel cheated. And then I asked him, why? Because this is usually a bad thing when Tom feels cheated, because then it means that I either made something really weird in the last pull request, or that I had an idea that he thought was good, and then he was thinking over the weekend that, not going there. But in this case, he was saying, like, you know what? Since I started working here, I thought that I was somehow special, that I figured out something amazing, that I was super smart, because I was programming functional programming, and especially Erlang, and that's considered to be super difficult. And it isn't. Because I looked into Java this weekend, and it doesn't make sense anymore. Because it's objects, and you do everything the wrong way of how you think, and it's just confusing. And I said, yeah, I totally agree. And then Tom said that, you know what? I bet that we could go to any high school class in Gothenburg, where we were at that moment, and we can teach them Erlang in 3 days. And then I said, oh, I really like the way you're thinking, but why don't we make it even a little bit trickier? Let's go to a 9th grade class, a bunch of 15-year-olds, like 25 or so, 15-year-olds, and we teach them Erlang in 3 hours. And Tom said, yeah, sure, let's do that. So I contacted my old math teacher that was still working at the same school, and I said, hello, do you remember me? I was the one who liked variables and not numbers. And can I come and borrow a couple of, a few students, and we can see if we can teach them programming. And he was actually, just at that time, about to start teaching programming. And he had gotten the advice to start with Python. And it was very confusing. He didn't really understand how and where to start. Students didn't really get it. So when we said that, what we want to teach is maybe not the most traditional go-to language if you would ask someone else. And then he said, I don't care, just teach them something, as long as it's programming. So that's what we did. So now we had a teacher who wanted to support us with this, with some students in a school. This is Nordhemskolan, by the way. It's a public school in Gothenburg. The bottleneck for even going there was that they didn't find enough computers to use. They had to start searching in their, everywhere at the school and find 20 computers. So it took us half a year until we could even go there. But now we had some students to test, some test bunnies, so to say. So then came the question, okay, we need to make this, because we didn't want to go there and be just another lesson like math or tech or biology or whatever. We wanted to do something, it should be maybe more like art or music, like a little bit more light and a little bit more fun. And we wanted the students to really enjoy those 3 hours. So we started thinking, okay, what makes programming interesting? For me, what makes programming interesting for me is the infinity of possibilities. In my opinion, you can build almost whatever you want. Everything is possible to build. It's just a matter of time and knowledge. And there is programming everywhere. When the students go out of bed in the morning, they will see programming as soon as they open their phone and start surfing social media. And then they go to the tram, and then they have the tickets, and they scan. And yeah, it's everywhere. It's already a very important part of our lives. You can implement programming everywhere. And what I mean with implemented, I mean with that you can combine programming with a hobby that the person that is supposed to learn programming already has. For example, it could be sports like soccer, horse riding. It could also be music, art. There's a very broad span, and you can if you really try, you can just think of a topic, and you could probably find some way of implementing programming on that topic. Another thing is that you can't fail. For example, when you learn how to cook, and you stand there for 3 hours or so, half an hour if you're me, and then you serve the food, and then the person says, it's too salty. And then you say, oh, too bad, then try again next week, or tomorrow, or whenever I have the opportunity. With programming, you write something, and it says, good, you did it, or it says, bah. Then you have to press Control-Z, and you do it again. And sometimes you even want the programs to fail, as we know. It can even be a really nice thing to just let it crash. You also get this, as said, an immediate feedback. It's not like you build something, like if you repaint a wall, and after half a year, this wall doesn't look as good anymore because you missed an important step. Of course, we know this can happen to programming as well. But it's somehow, when you work with small things, it's somehow easier to, you notice pretty quick if something is not working. So then came the question, okay, we know that we need to build something that is interesting, something maybe that has a purpose. So what should we build? What should we do? So we decided to build a chat room. Because when you're a student and you use the school computers, you're not allowed to use, for example, Facebook Messenger. And the teacher will recognize Facebook Messenger, but the teacher will not recognize if you open a terminal window. So it's somehow useful, right? You get immediate feedback. Either your message appears at the other computer or it doesn't. And you get somehow a motivation, because if someone sends you a message, you don't want to be that person that doesn't answer. And also, since we didn't know how many computers we would have, we didn't know if the students would have to share a lot of computers or if they would have one each, we figured, okay, let's have one computer as one node. And we just connect them to each other, and then we're good. So the day arrived, and we were super duper prepared. We had sent out a really ambitious paper a week ahead describing what a variable was and all the types like floats and integers, booleans, and you could have lists, and lists could contain a lot of things, and all those things that we thought was very important. I will come back to that. We also installed Erlang on 20 computers at the day of our session. It went extremely fast. It was super easy. We had these computers that we didn't know anything about before. We just installed it, and then we installed our sample program that we should use, everything up and running. And what we did was that we connected all the computers to each other, or at least we had them on the same network, make it possible to connect them. And we had a main screen in the front that was supposed to be somehow a monitor where everyone could send messages. So no one would feel excluded, like, oh, who should I send to it? Just send to the main screen. So then I come back to this. What is a variable? Let's start with something easy, right? Everyone knows this. It's the first thing you learn when you start studying programming. You learn this stuff. You don't really know how to use it yet, because you can't make any sense with it, but you know it. And what we also thought was that, because we had this conversation with the teacher before, and he said that this is the level they have in math, and we figured, okay, variables, at least they occur in math, so maybe they feel a little bit like home. So we described this, we helped them opening the terminal windows. They managed pretty quick to change the color of the text to green on a black background. It was super cool. And we started with the first things that they should try out. And we started with the first things. And this was the reaction we got. It was a little bit not really expected. And we figured, okay, what do we do now? And then it got even worse. It's like, it was syntax errors, exception errors. Oh, why do we do this? This is useless. This is boring. Can I throw the computer out the window? Can we build something cool now? And then 1.5 hours was up, and we had to go for lunch. And Tom and I, we were sitting there at the lunch room, and we were talking a little bit like, oh, what should we do? This is not going according to plan. We're supposed to know variables by now, and what do we do? Okay, shall we replan this? Maybe we should continue with this, or maybe we should say we failed. But then we figured, okay, it's already going really crappy right now. So let's just continue and pretend like nothing happened, and then we see, I mean, it can't get any worse, right? So we were a little bit, didn't feel perfect to show them this. But the thing is that when you show something like this and you describe it, okay, your first thing, you have to say the name of the module you're building. Oh, it's Skola. Great. Oh, okay, we have some functions. That's stuff that do things, just like in math. Okay, good. Yeah, good. Then there are different things, like you can start a lot of things at the same time. It's called processes or concurrency, just like in real world, right? Like if you play the drums here, and you can also, so you can have like a lot of different things happening at the same time, which makes it possible for you to send a message and receive a message basically at the same time. And then there is a mailbox, because you're supposed to be able to receive messages, and then you're supposed to be able to send messages, and you will figure out somehow the IP address of your friends. And we also helped them, of course, with the cookies and got them started, but I didn't add that here because there was no space. Yes, so the thing is with this chat room is that it's really nice. As I said, it's communicating between the nodes. You can send messages to each other. And there are these different parts. And as you notice, it isn't that much variables and things to know, really. And we were preparing for that. Okay, let's see how it goes. And it went good. We had all the students starting to send messages to each other, and we wondered, what did you do at lunchtime? And it was amazing. We were just standing there like, okay, and even the students that were the least interested started sending, because if someone sends a message to you, you send it back. And it went really well. So to evaluate this, the students really enjoyed the day, which we heard later on, and they especially liked this thing of writing messages to each other, because everyone got to be involved, and it was easier to keep up. You at least had something fun, even though you didn't really think the typing was fun. A lot of students want to get more information on how to start programming. They also asked us a lot of questions, and they were very fast learners. Most of the questions we got was, okay, how do I hack this? We actually had one of the students who realized that you can write a recursive function, and then you can spam the main monitor. Then he realized, luckily, after a while, that he had forgot to spawn a new process, so he couldn't do anything else and just start this recursively. And what do I do now? It's like, yeah, it's kind of taken here. So it went very, very well. And then we started thinking, okay, if this went good, shall we do it again? And then there were a lot of time in between that we didn't really have time. And then I contacted the teacher again and said, did the students have just as good time as we had? And he said, yeah, it's good. And I actually found some students that would really like to go for another try. So that ended up in a second session. It's just a couple of weeks ago, actually. So yeah. I got 2016. I got a diversity ticket to Code Mesh, London, and there was this really amazing talk about writing music with Erlang, with Joe Armstrong and Sam Aarons. And I wanted to write something like, oh, we can write something in Erlang and we could try to send it to Sonic Pi, but then Tom said, like, no, this is actually one of your bad ideas again, because this time we have students that are interested. So we should just have an application that they can download at home, and they can continue where they left off at the lesson. What is also interesting about these students is that they are all musicians. It's a music school, just like I went to myself. So it was kind of natural that we should, if we were supposed to choose a topic that they like, that it would be music. And as said, Sonic Pi is built by Sam Aaron. It is built with Erlang and Ruby. You write in Ruby right now. I really wish for having an interface for Erlang as well. Because that's the thing, the IDE, or like the GUI, is very intuitive. You have, I can actually show you this here. It looks like this. So you can write your code, and then you click Run, and then it will compile, and then it will show you underneath. It will pop up a window, and it will tell you that there's the bug, it's on this line, then the line turns red. And then you can also see on the right side there that the program is still running. This is written by one of the students. And when we were showing this the second time, when Tom started teaching, loops were a little bit tricky. They didn't really get that. But after they got that, they were like looking a little bit polite at us, and then they were typing there like, yeah, we pretend that we listen to what you say, but we are already started here. And it actually sounds really good. Too bad it doesn't play. So, to wrap this up, yes, you can teach functional programming to a school class. And a conclusion to this is that I think that programming definitely should be a subject in school. However, it's very easily compared with math, and programming is, as we know, not at all like math. I would say it's more like art or music or more like woodwork, needlework, whatever, but it's definitely not math. This is fun. A very important thing is, I think, to learn functional programming first. Because if you learn that first, as Victoria described it as well, that people usually tend to learn the imperative programming, and then they know how to think imperatively, or imperative, sorry. And then when it's time to go back to logic, which is logic, you don't remember how you were thinking anymore. So it's easier to learn than to have to relearn something. It actually takes about 10,000 times to relearn, to change something that you do. Someone have to tell you that 10,000 times. Find a very interesting topic, like music, sports, art, something that the students enjoy and that they could be interested in trying to implement with programming. And also find a purpose. Make sure that they can see a result if they do something right or wrong. When we were trying with the variables, they didn't see a clear result. They just saw, yeah, it writes out exactly what I wrote in. Or when I tried Hello World, and it was very disappointing. And in the end, and I know I'm a little bit early here, but it's far more important than having fun at this stage than how it's done. If they are interested in programming, they will find resources because there are so many amazing resources in how to learn how to program, but they need to have the interest first. So, thank you.
One, could you see it working with younger children? And the other is if your resources were more limited to, say, using an iPad.
I think that it's a very individual thing. I studied to become a writing instructor and judo trainer, and we learned I don't have any more education on how kids learn, but I think it's very individual. Like some kids will understand Erlang or any functional language at age 9, and other kids will not understand it till later. I would say that if it is presented right, I think Erlang is a good language. I don't want to say that. Ask me again in a year or so, and then I will know, because we want to try with younger kids as well. The second one is that the iPad. Well, there is a new way of doing graphical stuff in Erlang, I heard. So maybe if there is something like that coming up, we could have a nice ID for Erlang, then we could implement it there.
So in Stanford, that have the idea that you should start with functional, but I don't know what the basis for that is.
I am not really sure about that.
Well, I think any computer science degree needs to teach students, functional programming, imperative programming, logical programming, and object-oriented programming. Unfortunately, a lot of universities start with OO programming, and that makes then students believe that that is what they need to use. And so, starting with functional programming disrupts that idea and, gets students to start thinking in a particular way.
I was talking to someone teaching at Linköping University, where they actually start with Lisp, of all things. And the reason for that was that you teach people the higher level concepts first and don't actually care so much about how computers really work, but you care about how to structure data, and you have fewer constructs which you can do more things with. And I think that that's appealing.
If you know schools that would be interested in having programming courses, how could they contact you?
Easiest is to contact me by email, and then they will get in touch with me and Tom.
Just wanted to find out if you've ever applied the same approaches to maybe kids with disabilities, like slow thinkers, and can you apply the same principles?
I think programming is something that everyone can do. It's not only for some people, it's something for everyone.
Can you describe what is the advantage of functional programming as a first language? Because I was unfortunately not.
I can basically only go back to myself on that question. I learned by myself. I started with JavaScript, which you can write functional. And when I look back at the code, it is very functional. It's the way that I was thinking. And that was actually what also got me interested in this, that it is basically, when we ask someone who doesn't know programming, how would your approach be to turn on this lamp over there? They would say, I click the button, lamp goes on, I get a response like, oh, light is on. So our approach, what I think, is that we tend to think about what we want and not directly going into how do I want to do this? And then you're stuck. It's more of a, what do I want? What's my input? What's my output?
Yeah, so recently in Sweden we have started with adding programming as a part of a lot of subjects. And what do you think of that approach to teaching programming to kids?
I think as long as you have programming as a tool that makes it easier to understand the topic and not making it just trickier, for example, as long as it's a positive approach, then I think it's very good.
What do you think is the hardest part? A difficult approach will solve that, or is more like a Sonic Pi approach?
I think it's very easy when you learn programming, and I also come back to myself, that you get kind of impatient, and you want to learn everything directly, and you want to create amazing things. And for that, a tool like Sonic Pi is very good, because you create something. But then, of course, when it comes to learn how to program, there are no shortcuts. You have to kind of learn the language, and then you can start adding things up. But I think, obviously, this chat application was also very, very good, very successful for us. So I don't think it really matters, as long as the challenge is good for the target group or for the students.
What was the most challenging concept that you had to explain to the students? Like, was it the receive, or there are different nodes, or the sending, or just variables, or yeah?
First of all, it was the variables, that they didn't really see the purpose with knowing them, and then it was the loops. That actually the function would call itself all of a sudden without you telling it to.
Yes, thanks for the amazing talk. Did you ever have plans to introduce same programming courses for elder people? Would the approach you used to teach kids work with elder people? That's it.
Yeah, we actually want to try a little bit. We had an idea of trying with first-year university students, for example, to teach them functional programming before they get destroyed with the imperative one. I also did a very short, just a sidetrack, but I tried to teach my grandma. She's 92, and that was useless. Don't try that. At least not my grandma. Everyone else probably, but not her, because she didn't see the benefit of it.
Thanks for a lot of good questions and a fantastic talk. Once again, Madeleine Malmsten. Big hand.
Thank you.